Okay, hi everybody. Today is Thursday, June 29th. This is SIG Scalability, a publicly recorded meeting which will be posted to the Kubernetes YouTube channel as time permits. Just a note of administrivia there, we're having some file corruption flail with some of the recent recordings that were made to this computer. So we may be down a meeting recording or two. I can let Bob fill in on that when he steps back in the room. As far as 1.7 goes, Merrick, I may actually be looking to you for some more clarity on what's been going on with the scalability cluster, but my high-level understanding is that we have not made the enormous cluster a release blocker for the release of 1.7, and what had previously been failing was the introduction of services into our scalability-related tests. When we removed services and ran the scalability tests, we expected them to pass, but we weren't going to hold up the release for that one way or the other. And the other thing that had been impacting the scalability tests was a subnet-related change for the enormous cluster.
Well, there were more. There was also the problem with the new node authorizer and generating certs, which is slow, and it basically just like made it impossible to create large clusters. But this is already fixed. About performance, when we disabled services, like the test passed, though like on 4,000 nodes, but like the margin was big enough to suggest that on 5,000 nodes it would pass as well. So we are good from the performance side, at least there.
So a high-level summary I thought I saw posted somewhere yesterday was that we're basically exactly where we were at with 1.6 as far as the data shows.
Yep, we run the same tests as for 1.6, and they give the same, well, roughly the same results.
Okay.
In case we understand more, like we found a number of issues that we will be fixing, like we or someone will be fixing, like lack of backoff in NPD or kubelet when something goes wrong, so it just causes like a storm of updates in the API server, which just starts to respond 429 on everything, which then make more stuff fail.
So it turns out that actually pretty much all the node agents had some kind of problems because so like we got IP masquerading agent removed from the release because it was ooming, and then there were issues with kubelet and NPD sending too many events patch requests while they shouldn't be doing, and it turns out it could be an issue with client Go that you're not backing off on server too busy issues. And kubeproxy was failing to restore IP tables, and due to that, it was actually printing a line in logs, it was trying to print out the whole IP tables, which was ooming Fluentd, and as a result, Fluentd was getting oom killed. And so it's like it's kind of a complex interaction between all these, which ended up like creating quite some issues, but we more or less resolved them now. So we changed kubeproxy logging to actually stop ooming Fluentd on large clusters, and of course IP masquerading agent has been removed. So by removing ooms, we made sure that actually kubelet and NPD are also not sending too many requests, but like we identified quite some bugs around node daemons due to running it on the scale, but yeah. Otherwise, we are good. Like we didn't run 5,000, but yes, 4,000 was quite good, like Marek says. And
to be clear, when we're talking about 4,000, we're talking about 4,000 actual physical nodes. We're not talking about 4,000 kubemark hollow nodes.
Yeah, kubemark is passing. Like kubemark 5,000 is passing. Like there were some problems with tests themselves, but like they were fixed. So this is fine.
Yeah,
Yeah. So basically, like on the high level, we discovered a problem in the client Go. We actually not the client Go itself, as Daniel claims it's by design, but like in how the client Go is used. So like no one actually sets the backup manager of anything that's actually does any backup, which of course is wrong.
It doesn't have backup by default. That's.
I think the conclusion was that the default backup is 0. So like you can multiply 0 by 2 how many times you like, but it wouldn't change too much.
That's a great default. My other bit of 1.7 release administrivia, having not checked in personally, is this group, has anybody here taken a look at the release notes? Do we feel like scalability is accurately represented in the release notes draft?
I didn't. No.
I didn't too.
There was an email sent out that said technically yesterday at noon Pacific was the cutoff, and then as usual, the release group is proceeding with its usual level of organization. So like seriously, somebody here, please take a look at the release notes draft that's in the features repo. I've seen a bunch of pull requests on it today. Just make sure if there's something that scalability really cared about for 1.7, that it's accurately represented in those release notes, because last I heard, the intent was go, no go by 1 p.m. today. And as far as I know,
go, no go was like yesterday. So like, and like actually, like to be fair, like Don, like I was present on some release meetings, and I discussed with Don a lot about like the situation we are in. So like, they have the.
Yeah, no, I like from a cutting bits perspective, you're right. Yesterday, everybody felt good. Last I heard was that there were still some issues with the upgrade test, but it was a known regression. But just in terms of documentation, you know, it would be helpful if somebody from this group made sure that the scalability stuff was actually represented in the release notes. You don't get a chance to change those once it goes out the door.
Yeah, well, yes, though, like if it's today noon, we just, well, have to work already for us.
That's all I have.
Good.
I thought we had something to discuss that was postponed. Sorry.
I am not recalling anything at this point.
Well, since I see Clayton's on the meeting, there's something in the June 22nd meeting notes about memory utilization has increased from 1.6 to 1.7, and we should revisit our control plane node sizing recommendations. Clayton will care a lot is in the meeting notes.
I think that comment came from Tim, who's not here.
Oh, okay, yeah. So do we have a number on the memory utilization? I've been kind of tracking a lot of the controller side and API server side, but this was node size?
No, I think this is like controller size.
This was node size. This was like this, like a lot of we saw a lot of ooms when we ran the test with services for the first time, and it was solved by this IP master agent that was running for.
Yeah, that was on the nodes, right?
Yep.
So I know, like in 1.7, we finished up a lot of the informers stuff for duplicated caches. You know, I think Tim and I had talked a little bit about very large cluster memory utilization a couple of weeks ago, but I didn't have any concrete items for this, so.
Can you quantify what do you mean by very large cluster?
10,000 application clusters. So these are somewhere between 200 and 400 nodes, but 10,000 namespaces with, large numbers of both RBAC as well as so it's 10,000 services, and somewhere between 10,000 and 30,000 pods, depending on this. But that was my two topics actually for this week. Was the high apps number of clusters are seeing just a set of scalability challenges that are almost orthogonal to our current node density challenges, both around endpoints and events. So we can talk about that. Those clusters are the ones, like, that's where we're seeing a lot of the challenges today, rather than memory use right now.
Yeah, so for events, we are planning to do some major fixes this quarter, but like I try to start writing anything about it, but like because of the release and all the tests around it, I just kind of.
Yeah, I mean, Derek has his, so Derek made a number of small changes, and then he had the one change that we kicked out of 1.7, which is even more dedupe and back pressure from clients. So
you mean the span one, or which one?
For
one,
events.
But the one that like kind of removes spammy events, or the other one, like some other one that I don't know of.
I didn't catch what you said about which one it was.
Because there was like a number of small changes, and like you said that one of them were kicked out of 1.7. Which one?
Yeah. The one that was kicked out was the dedupe on the client side. So we have a dedupe mechanism and rate limiting on the client side. Derek basically made it more aggressive. So if you're sending, basically if the client is sending the same event over and over and over again, there's no point to sending that on to the master. And so basically he did something similar to what we do with both container and image pullback offs, which is effectively if the client wants to send the same event over and over, just back off sending and queue them up and eventually flush them. And the number he was targeting, just based on some empirical research on these clusters, was about 5 minutes. So as an example, a node that's in, or a pod that's in crash loop backoff sends like 5 events per container create. And so there's some clusters that we have where there are pods that have sent the same event over 1 million times, just because they send the same events over and over and over and over and over again as they're in crash loop backoff. And so that's what I mean by bad apps. So any unhealthy app effectively can bring down the cluster because we don't scale well to that number. And so the first part of Derek's change, the one that we did kick out, was basically a client-side spam rate limit filter that coalesces identical events. And then his other smaller changes were making more of the events identical, so removing uniqueifiers that made every event different. There's some usability trade-offs there. I just don't know that we can, unless we totally rip events out, I don't know what other options we have other than reducing the amount of uniqueifying info in events that are effectively sent every 5 minutes from, pathological pods or pathological nodes.
But like most of them are kind of useless. Like no one cares about container ID.
Yeah, and we'll probably have some others. So like definitely we get this on. I suspect we'll see this more from network plugins and other ancillary components where someone will introduce it, a new event will get sent, it's too unique. We'll just go through the process of, hey, we've got to go fix this because it's too uniqueifying. I don't think we're going to be able to review every single event that gets added to the system. So some of this is just going to be reactive. The other proposal that Derek had punted around but didn't actually get to, he's on vacation this week, which is why I'm representing him, was on the server side, do more to dedupe events for objects and rate limit either at a namespace or an event level per API server. So effectively do back pressure from the server on events when certain objects are just receiving too many events. So both at the namespace scope or at an individual object scope, whichever, we hadn't really gone far on this, would be if you have a particular namespace which has a bunch of broken apps in it, or it's likely that there's correlated problems going on, and you may not be able to get all of the events to be unified, but if the namespace itself had a rate limit or some other characteristic of that namespace had a rate limit, we might be able to keep to back pressure from the server to the clients, and then the clients to do more aggressive deduping as necessary. That was kind of a second step that he hadn't really put a proposal up for yet.
I had an idea of like introducing like some config, like whatever config map somewhere or whatever, like the top level that will kind of steer which events are published. So for example, like if you would be able to block the all events in the cluster if you need to, like the panic button. And also if it can be extended to just like actually to do the drag pressure as well.
Yeah. And we haven't really run into any cases of people being jerks on this, where people are using the fact that they can create events to be abusive. So I'm not particularly as concerned about that as I am just we ship a version of Cube that has an event that in a rare condition, 0.1% of the time, just can be completely disproportionate in terms of use. So I think something like that, a per event style filter might actually be a good compromise for cluster operators who are seeing abuse. I mean, all the other options we've talked about, obviously improving events in other ways will help. But without completely breaking the system, the only two things that Derek and I had come up with were filtering, compression, and back pressure.
Yeah, well, batching also, right?
Batching, yeah. Had anybody looked at the batching on the server side?
Batching on the server side. So using the fact that etcd3 user can have these multi-object transactions or some other kind of batching?
Yeah, I don't know. I mean, I think one of the challenges would be the multi-object transactions. You'd want them to be able to avoid conflicts. And we wouldn't be able to get the granularity there if different API servers in an HA setup were editing. So it might have to be batching on the client side, but that is an example of something that, we had talked about. I mean, I had the assumption that most events are going to be generated by the same process that would be candidates for batching, in which case, if we batched on the client side, we would see an advantage there.
Yeah, that's kind of my thought as well.
So just in general, like we are seeing events are the number one cause of this. We actually haven't noticed, and the 5,000 node cluster issue with Ooming, the increased event load wasn't the most critical path there, but like the scenario we keep running into is we can't actually go fix the individual applications because there's too many of them and they're all failing in different ways. And so just assuming that some percentage of the cluster is going to be pathological on denser clusters, maybe something we want to fit into our SLOs, which is Kubernetes is tolerant to 5% of pods being in a crash loop backoff state or something like that.
Yeah, like this is the thing that I actually also wanted to ask you, because currently we are concentrating on latencies and stuff, but we actually do not have any numbers, like how many services we want to serve or namespaces we have in a cluster or whatever, like how big from the app perspective the clusters needs to be. So if you have any input on how I probably should have, how many various kinds of objects we need to be able to serve, it would be very helpful.
Yeah, I mean, I think this is the multi-tenancy versus single tenancy app clusters, which is high levels of org users is an unusual case in me. So, we're kind of targeting somewhere between 10,000 and 20,000 namespaces. Some of the challenges we actually have is that a lot of the policy resources scale proportional to namespace. So secrets are actually the worst offender for us right now because we create in OpenShift pull secrets based on the service account token and then auto-mount those. Because we end up having to create that, we end up having 2 extra secrets and we create more default out-of-the-box service accounts. So we end up having 9 secrets per namespace. And those 9 secrets all reference the CA. The service account token does, and then each of the 2 pull secrets actually does as well. And so we have something like 65K of secrets per namespace, and the more CAs you add, which again is something people are starting to do because they, how do I distribute a CA to everybody in my cluster? we've been talking about that. That's the worst one right now. We've been talking about that just in terms of the SIG auth secret work, which is we'd like to stop storing a lot of those secrets in etcd altogether. And instead, clients that want to get access to, for instance, a service account token would hit a sub-resource or something that would have the ability to either fetch that from a remote system or to even generate it on demand, which there's some advantages to both of those, like only returning the CA when you ask for it, for instance. So that's the worst one. We haven't really hit many issues with policy. That one's actually fairly well optimized. Endpoints is the other one. So what we were actually seeing with events, with endpoints, is failing pods cause high event traffic cause high endpoint traffic, and high endpoint traffic got to the point where we were relisting endpoints every 30 seconds. So every 30 seconds, we'd process 10,000 individual services. Any flapping there would result in multi-tens of second delays before new endpoints were taken because the endpoints controller was hitting rate limits. And so I think the changes in 1.8 are very useful, are probably going to address most of them. But the question had come up was, would we backport these? And assuming we get sufficient soak time on them, they're not huge changes. I suspect, we've had reports of users hitting it. We know we're hitting it. I don't know if others have yet started to see this in their clusters, but it seemed like this is one that might be reasonable to backport.
Yeah, well, there was a discussion if you want to put it in 1.7, in the first place. So, I think they kind of, if you want to put it in the patch release, it's probably possible.
Yeah, it's definitely the endpoints controller hasn't changed much over the last year and a half. So once we have soak time on 1.8 in the big clusters, I'm probably not worried about it. I worry about it in the sense of we're going from a model where we were checking everything repeatedly, and now we're depending on the infrastructure to be correct. So I'd hate to introduce random flakes and endpoints without sufficient tests. So
that's true. Fair enough. Yeah, but basically what I would like from this SIG is to actually define those numbers, how many some kind of the limits on number of apps or objects that we want to support. So currently, the only thing that we kind of say is what we do in tests, which is by far not perfect because those numbers were pretty much arbitrary. They're just chosen by because someone felt it at some point. Yeah. So if we can have some input from other SIGs and owners of whatever networking and something, of how many of objects of given kind do they think they can support, or how they scale even, if it's linear or how very quadratic the networking is.
Yeah. One other thing we've noticed is write volume to etcd really is the scale limit that we hit the most on clusters, because we have even, at a certain point, you can't throw more CPU and networking and disk at etcd from the perspective of how many writes per second you can do. And so we've seen this failure mode over and over and over is some component goes out of whack and consumes almost or all of the write budget in a given time interval, and everything else just falls apart. We have not really ever discussed a component level balance on writes, where at some level it's just impossible for the endpoints controller to write events or more than a certain number of events. There's a lot of pathological defensiveness cases that it might be useful there. I don't have a great answer for how we might do that, but we see this from things like the kubelets, things like the controllers, and then people building integrations on top of the platform that just have a weird edge case. Well, if that weird edge case and I'm not blaming, this is just an example, the etcd operator can bring down a cluster, we're in some level of trouble. And today we depend on reasonable client behavior, and I don't know that we can keep depending on that as our clusters get more extensible.
Yeah.
Another topic.
Certainly making me feel like our current position with regards to the cluster configs of sticking with split etcd is the right call for now. You don't think it's
split event etcd or splitting etcd from the master machine?
Splitting of the events etcd into its own.
Oh yes.
There was a little bit of debate about that, but I think this discussion at least makes it clear that's a good idea, at least on the bigger clusters.
There's a reason why you did it, right?
Yeah. Clayton, a question for you on I think you said two numbers that stick in my head. One of them was, let's say, 400 nodes, and the other was 10,000 namespaces. Do you think if you went to 4,000 nodes, that means an equivalent multiplication on the namespace number, or?
No, I mean, so in practice, what I think we see is there's really just two types of clusters in the world. There's the ones where people are trying to get density for like ad hoc development experimentation. And then there's the ones that are a little bit more production focused, like you're building a cluster for a purpose. Even though I've heard people say like, oh yeah, I want to run 4,000, 5,000 node clusters with 1 million apps in there. Nobody's going to be there for a very, very long time. So I think it might actually be reasonable to say what we've just been thinking about is like 10,000 namespaces, 100,000 pods is actually a very aggressive, because like to get 10,000 or 20,000 namespaces, you really need that many tenants, and tenants tend to not create that many things or have that many things running. Like I think about like the number of developers organizations in the world that have 10,000 developers, and each of those developers has multiple long running apps.
I think let's put the Google internal example aside, the Borg case. Putting that aside, I think the most aggressive one that I know of is Uber, and I think Uber they're not actually sure, according to the people I talk to, how many microservices they have, but they're probably between 4,000 and 5,000 microservices. And if you're talking about a service per namespace, which I think is the model you're targeting here, your 10,000 is still 2x a pretty major entire large company, right?
And we've seen denser clusters than that. It tends to be more of the dev style playgrounds where people create a lot of things and then forget about them, versus like the Uber 4,000 microservices. Like I wouldn't expect that all in one cluster no matter what, to some degree.
That just makes the case that I mean, even if it were all in the same cluster, your number is still aggressive, right?
Yeah. And like from what I'm aware of, like at the banks, I'm not aware of any cluster software today at the banks that's running significantly more than 10,000 applications in the same homogeneous control plane. And so like, I think it is I think it's within, certainly that estimate, 10,000 namespaces is less than an order of magnitude, probably from a reasonable practical limit for many years, for many people. I'm sure there'll always be outliers, but.
Right. Okay.
Yeah, so we will probably need to start writing those numbers down and like making sure that it's actually
Are we done for today? I think we're officially out of time. That was a pretty good discussion. I did have one bit of bookkeeping administrivia, which is next week, at least here, because of the 4th of July holiday, a lot of people are taking off. I'm wondering if folks want to plan to meet next week, if there's enough people around, or whether we should cancel for next week.
Well, we don't care about 4th of July.
Anyone else? I mean, you and Wojtek can certainly show up here on the call and have a chat with each other. All right, well, let me see. I'll see if I can get some consensus from anyone else. But we won't cancel the meeting unless it's clear we should. There may be enough people around. I'm going to be out though. I think, are you going to be out as well?
I'll be around.
You'll be around. Okay, so maybe you can cover it then. All right. See everyone at the community meeting.
See you.
Yeah.